Okay, hello everyone. Welcome to ENGR 210 review session 3. Today is February 6th, 2025. And today we are going to be mainly covering mesh current and then the what's it called? And source superposition. Also, just as a reminder, my office hours. I do have office hours. I'm just putting this out there because I haven't had too many people come to them. They're kind of at an odd time, but if you want personalized help, Zorman has office hours, Samantha has office hours. I do too. My office hours are Monday from 10:30 a.m. to 11:30 a.m. in the Glennon, I cannot spell, Glennon ECSE Lounge. Yeah. So if you need help with this class, feel free to show up then and I can give you a bit more personalized help. So to get started, the two things we're going to cover first are mesh current, and I will just get into that. So mesh current is like node voltage, which we covered last week. Mesh current is a method of getting equations to solve a circuit. For node voltage, we looked at circuits that kind of look like this, where there's a bunch of like things coming out of nodes, and it might be convenient to write equations based on, you know, one of those nodes at a time. For mesh current, it's a bit more convenient when you have things like current sources and there's like a lot of loops next to each other. So it's like, let's make up a circuit on the spot here. We got current source, a resistor, some voltage source here, another resistor, another voltage source. And then maybe over here we got a resistor, a long wire, and another resistor. So let's say we have a circuit like this, and we want to figure out stuff about it. Let's label all these resistors with various, let's pretend all of them are the same resistance for the sake of this, because this is just an example. Okay, so the key thing with mesh current is that we are using KVL, which is the sum of all voltages around a loop is equal to 0. So what that means is that basically the voltage rises around any one of these loops is the same as the voltage falls or the voltage drops. In other words, if we go up some amount of volts here and down some amount of volts here, then like the difference in those, or basically we'll go up the same amount that we go down, no matter what, for any loop. And you can use that to write equations. So those equations, what we do is we start by kind of making up, I'd say like component currents. So let's say we have I1, we have one current for each of these loops. We'll call them I1, I2, I3. And you can kind of pick whatever direction you want. I generally choose clockwise. It doesn't matter what you pick. It doesn't matter which one you call what. But let's say we have I1, I2, and I3. And then what we do is we write for each of these loops, we're going to write a KVL equation for it. So for I1, and the key thing with these KVL equations is that they are voltages in the equations. So I'll show you what I mean by that in a moment. Okay, actually, I'm going to start with I2 because it'll make a bit more sense for this example. So for I2, right, we're looking at this loop. So start with whatever component you want, and we're going to write an equation. So for I2, we look at the voltage of each component. And so you sum all of them and then set that equal to 0. And that's your equation. So if I'm starting with this voltage source on the left, I'll call that V1 and the one on the right V2. We would have, okay, we've defined I1 as going this way around the loop, or we've defined I2 as going that way around the loop. So this would be a negative V1. And then, okay, there's nothing on the top. We keep going, and then we get to V2. V2, that would be positive by passive sign convention. Hopefully you all are familiar with that by now. And then last but not least, we would have this resistor. And resistors are always going to have a positive voltage. And the voltage across the resistor, again, V equals IR. Hopefully you all are familiar with that by now. So this would be I2 times R. And you set that all equal to 0. That's like dead simple, simplest thing you can have. Something more representative of what you might have seen in class a bit more is I'll do I3 next. So for I3, let's say I start with this resistor on top. So it'll be I3 times R, and then the one on the bottom would again be I3 times R. Kind of a bad example here. But then we'd also have to deal with this same V2. However, now, since we've defined the current as going clockwise, on this side, V2 will actually be negative. So it'll be negative V2. And then for this resistor, the voltage across this resistor is not simply I3 times R. It would be, okay, we have this way going this way, or we have I3 going that way, and then we have I1 going down. Since we are kind of writing the I3 equation, we're going to say that I3 is positive, and then the resultant current through here, we can like imagine it like that, would be I3 minus I1, because I3 is going up and I1 is going down. They'd cancel out somewhat. So we would say then plus I3 minus I1 times R, and that equals 0. And then for the last one, for I1, this is something where some people get tripped up. Here, we see, okay, we have a resistor, and then we have a current source. And this current source is just, it's only attached to I1. So if we have I1 flowing around here, right? But on this loop, we see that, oh, somewhere along the way, we have a current source. And the current source says, oh, we have this amount of current flowing on this part. Then we can very simply just say I1 equals this current that I've defined here. So that's just basic overview of how this would work with a circuit I made up on the spot. Cool. So I'll do like 2 or 3 examples of that today. And then the other thing that we're going to go over is source superposition, which basically says that the contribution to like the contribution to anything in a circuit, it's like the sources are independent of one another, and you can make a circuit with one source and then make a circuit with another source and then like add the result of those two together. So for example, like the most simple example is, let's say we have a current source here, a resistor in the middle, and we have a voltage source here, a resistor in the middle. This has some resistance, this has some current, this has some voltage. And then what we can say is that if we want to find, actually, this is kind of a stupid example, but I guess this is something I'm not going to do this here because you'll see it in a sec. But if we have this and we want to find like the voltage across this resistor, what we can do is we can split this into 2 different circuits. One of them we cancel the current source and solve. One of them we cancel the voltage source and solve. So, and then a brief aside on neutralizing sources actually. So if I have a current source, let me neutralizing sources. If I have a current source, opposite of a current source is no current, i.e. open circuit. So when you're neutralizing a current source, it would become an open circuit. And when you're neutralizing a voltage source, opposite a voltage source is no voltage difference or no voltage change, i.e. a wire. So it would just become like you can do a little symbol like that to show that there's just nothing there. Um, so if you ever, you'll have to do this for various things in this class, but when you're neutralizing sources, just remember that you basically turn it into the opposite of what it is. So a current source provides current. The opposite of a current source, neutralizing the source, would be having no current. Likewise, a voltage source creates a voltage difference between the two sides of it. The opposite of that would be no voltage difference between the two sides of it, which is just a wire. So you can think of a wire as like a 0 volt voltage source, and you can think of an open circuit as like a zero current source if you want. Anyway, going back to here, we neutralize one source at a time. So let's say on the top one, we neutralize that current source. And on the bottom one, we neutralize the voltage source. And then we find our, let's call it V prime. And here we'd call it our or VR prime prime. And then we take these two and say that, okay, the real VR is equal to VR prime plus VR prime prime. Yeah. And this, at least for circuits with like just resistors and voltage and current sources, this works perfectly fine because all of those components are like linear, if you know what that means in terms of like math. And yeah. So with that, I will just get to practice problems. I'll do like 2 or 3 mesh current ones, and then I'll shoot for like two of each, I guess. This quiz will probably be like one mesh current question where you draw or you write the equations similar to the previous quiz. And then the second question will be a probably like a superposition question where you actually have to find a number. So yeah, starting off, I'll do a mesh current question. Pretty straightforward mesh current question. And yeah, if you're not certain about your passive sign convention, I would make sure you are very solid on that because that is somewhere where you can lose points unnecessarily on this quiz. So this says, I'm actually going to take another second to write this because it's kind of a long circuit. Got to put in the values and stuff. Okay. Oh, one more thing. Okay, so write all equations to find IX. So what we have here is we have 3 meshes. So we're going to start by, just writing out or labeling which direction our currents are flowing. As I said, I always like doing them all clockwise. You can pick whatever you want, but just be consistent with your math. I'll arbitrarily call that one I1, I2, and this one I3, and then I'll get to writing equations. So probably label your equations. So for I1, we have 4 components on I1. I'll start with that 2 ohm resistor on the left. Since the 2 ohm resistor is only interacting with I1, this one's very simple. It's just 2 times I1. That's that term. You can put in the units if you want, but it doesn't really matter. Is Thevenin equivalent not coming on this quiz? I think probably not, judging from previous years. I think that one would be on the next quiz. Let me make sure. Yeah, Thevenin equivalent's probably on the next quiz. If you learned it on Wednesday, it probably won't be on this quiz. That'd be kind of mean. Generally, the quizzes have the same stuff that the homework does. So, or there was like one. Yeah, but this quiz will more likely than not just be mesh current and superposition. Anyway, continuing with this question. So we did that 2 ohm, and now we're going to do the 3 ohm on top of the I1 mesh. So we got that 3. I'll write units. I'll be nice. It'll make it look a bit nicer. So 3 ohms, and then that's going to be times, okay, as we said earlier, we look at it here. We have the I1 going that way, and we have I3 going that way. So the resulting current from the perspective of the I1 loop would be I1 minus I3. And then we do the same thing for that next 2 ohm resistor, plus 2 ohms times I1 minus I2. And then for the voltage source, remember what we do for voltage sources. Since each of these terms, right, we have R times I, that's a voltage. We have R times I. Remember, all the terms in this equation should be a voltage. And we have a voltage source, so we just write what the voltage is. Since we've defined the I1 as going down there, the voltage drop is in the same direction as the current. So we say this is a positive 48 volts. And then that's all the components. So we just say that equals 0. And that's our first equation. For I2, we do basically the same thing. I'll start with the 48 volt source. Now, since the current is going in the other way, like relative to the voltage rise or drop, this is now going to be a minus 48 volts. That 2 ohm, or that 2 ohm resistor is now the opposite of what we said before. Now it'll be I2 minus I1. Since from the perspective of I2, I1 is the one going backwards. So I1 would be the negative one. Then we have the 6 ohm. Oh, that's not a, be plus 6 ohms times I2 minus I3. And then that all equals 0. And that's all we have for that equation. And then for I3, before you look at anything, you see, okay, we have a current source. What do we do with the current source? You don't know the voltage over a current source, so you don't write that. And it's just the very simple thing I said earlier. I3 here would be negative 4 amps. It's negative because we have defined I3 as going this way, but the current source tells us that there's actually 4 amps going that way. So in terms of I3, like it would be negative. So we write it, the actual equation, as just I3 equals negative 4 amps. And then remember, it's saying write all equations to find Ix. So what would Ix be here? Well, Ix is the current going through this 6 ohm resistor. What is the current going through this 6 ohm resistor? Well, we have other currents to work with here. So what would that be in terms of I1, I2, and I3? So since Ix is going to the right, the positive one would be I2, and the negative one would be I3. And you can just kind of write it as the sum of them. So we'd say Ix equals I2 minus I3. Hopefully that's pretty clear. Basically, we make up these 3 component currents and then use those to write equations, and you could use these to solve for everything in the circuit. And yeah, so this all would be your answer to the question. And that would be perfect score on your quiz. Moving on, I'll do, yeah, this one's more complicated, so this is good. Um, we got, this will take me a second to draw. Well, spam risk, my favorite. Um, okay, sorry about that. So many spam calls recently. I need to figure out how to get myself off their lists. Okay, and this one we have a dependent source, but you'll see that we end up treating it in the exact same way. Can I explain the last part again? Okay, I'll go back. So here, the question was saying find Ix, and Ix, given by the question, is defined as this current going to the right on top of this. So Ix, the question has asked, okay, what is this current? What is the actual current going to the right here? From our equations, we can solve to figure out what our I2 and I3 are. I2 and I3 are these variables that we create to help us solve the circuit. And you could use these and you'd get I1 equals blah, I2 equals blah, and I3, well, we already know it's 4 amps, but we'll get that. And then, so if we know around this loop, there is, around this loop, there is some current flowing, and around this loop, there is some current flowing. That means that we can think of this IX up here as having some component flowing to the left from I3 and some component flowing to the right from I2. And since IX is defined as going to the right, the positive one then would be I2. And basically you just write it as a subtraction of those two currents. We have one going to the right and one going to the left, and it works out. Back to here. I will finish drawing the circuit. 6 ohms. Okay, so we have this, and there's a lot of loops, but we still do like the exact same thing. Gonna create or label all our currents, I1, I2, I3, I4, and I5. I forgot to label this voltage source. It's 12 volts. Okay. Then this is saying just write all the equations to solve the circuit. You're not finding anything in particular here. Just all the equations that you might need to figure out anything. So I'll just go in order from mesh 1 to mesh 5. So for that I1, right, we simply find that, I1 equals -3 amps. Pretty straightforward. If you wanted to, you could even like leave this equation out and then just in the I2 equation, you can just like instead of saying I2 minus I1, you can just say I2 minus 3 amps. That's an option. But just for consistency, it can be nice to just label everything properly like this. So then I2, we got 4 times I2 minus I1. This is where I was saying you could just write 3 amps there because or you could say plus 3 amps there, I guess, or minus 3 amps, whatever you want. But I will leave it in the variable form for now just to be consistent. Then on the top, we have 6 times I2 minus I5. On the right, we have 10 times I2 minus I3. And then with this voltage source, even though it's a dependent source, you just treat it exactly the same as you'd treat any other voltage source. Since the voltage drop is in the direction of current, this one is positive. So this is then just going to be plus 2Vx, and that's everything, so that equals 0. Moving on, I3. We'll start with the voltage source again. Now, since the current is going the other way, right, it's now going to be a minus 2Vx. And then again, the 10 ohm resistor, and this is going to be the opposite. This one is I2 minus I3. Now it's I3 minus I2. And then plus, here you can either say 8 times I3 minus I5, right? Because we have I3 on the bottom and I5 on the top. Or you could also instead just write Vx. Either works. I will write it like this because it's a resistor, and I will do this to be consistent. And then finally, we have that 2 ohm resistor, I3 minus I4. And then for current mesh 4, okay, we have this dependent current source. And since it's a current source, it just tells us the current. So I4 equals, and since we've defined it as going down here, since it's a counterclockwise, or since it's a clockwise loop, this would actually be minus 3 IX. Again, for the voltage source, please review passive sign convention. If you have current flowing in the direction where it goes from positive to negative, we write this as positive voltage. Think like resistors. And if we have it going the other way, where the voltage rises, then this would be negative voltage. This is just passive. Oh, for the resistor. Sorry. Which resistor was this? Would Oh, yes. For Oh, good point. If you were doing this here, the resistor itself will still have this voltage, but if I wanted to use Vx in this equation, this would have to be negative Vx. Yeah. Basically, I haven't gotten to it yet, but when you're writing the dependent source equations, yeah, you would say that Vx equals 8 times I5 minus I3 because you want it to drop in that direction. Yeah, good catch. Thank you for pointing that out. But I will leave that erased until I get there. Hopefully that hopefully that clears it. Um, and then last but not least for the meshes, we have I5. So I'll start with the 8 ohm. We have 8 times I5 minus I3 plus 6 times I5 minus I2. And then here, the current is going in the direction of the voltage drop, so it's just plus 12 volts equals 0. And then we have two variables for the dependent sources here. I'll start with Vx. So as I said before, the Vx has the positive on the right and the negative on the left. So that implies that current is flowing like leftwards on it. If current is flowing leftwards or to the left, then the voltage across it would be that 8 ohms times I5 minus I3. Again, because we've kind of, since Vx is defined as plus on the right, minus on the left, that implies that the current is flowing to the left, and the loop that agrees with that is I5. So I5 will be positive, I3 will be negative. Yeah. You could also choose to write this as like negative 8 I3 minus I5 if you wanted to. It's the same thing mathematically. And then, oh, I didn't label this earlier. Sorry. This is IX. It's over here. That's given in the question. So then what is IX? IX would be I1 minus I2 because I1 is going down, I2 is going up, and IX is going down. Yeah. And you could also write this as like negative 3 amps minus I2 because I1 from here, Yeah. So there, that would be your question. You write all of these equations and you get your answer and you're happy. I still got half an hour. Wow. Okay. So I have like, oh, what do I have? This isn't really useful, is it? This one. I mean, there's not much more to show for this. I'll do one more and do it really fast, just to show like how fast you can do these. Okay. Write equations to find V2. Yep, I don't know why it's called V2. There's no V1 given in this question. Uh, but yeah, again, we do the exact same thing. We call this I1, I2, I3, and I4, and we just get to it. Sec. Hold up. Can I write IX in terms of? Let me see. Wait. Right. Okay, so for this question, I have a couple questions in the chat. So can you write I4 in terms of IX? We already kind of did that. The question was, can you write IX in terms of I4? Like we did that when we were writing this equation, right? But we just said it the other way around. However, this equation doesn't actually tell us anything about IX. We have to get IX from the other things. The point of this is that we have five unknowns in here, and then we have another one from IX and another one from VX. So we have seven unknowns. That means we have to get seven equations, or else it won't work. Even if this equation is simple, like we just have another simple equation here to balance it out. And then would it not be 4 I3 minus I1? 4. Oh, and then so for this first question, the question was, would you not have to also have like 4 times, or wait, which is this? I1 minus I3? There's no situation in which you'd have I1 minus I3 here, but I'm guessing what you're asking is like I1 minus I2. So this voltage drop indeed is 4 times I1 minus I2, but since we have a current source here, that kind of is just giving us information that, okay, we know there's a current flowing down there, and we've defined I1 as going like this. If we know there's a current here, this part of the circuit is only affected by I1, right? So if I1 flows through here like that, but we know the current is going like that because there's a current source, it's defining the current as flowing like that, um, then then you can just write this equation and be done with it. There, you don't have to do anything else. Okay, then can we do some problems that not in a line, but um, I don't exactly know what you're asking, but you're just asking me to do a different kind of practice problem, and see if I have one that has more like shared walls. This one was pretty box-like, but I'm gonna do this one here real quick. Okay, so I1 is just 40 I1 plus 50 volts equals 0. I2, going fast on this. Okay, we got minus 50 volts plus 5 times I2. I didn't need to put parentheses there because it's just affected by that one. Plus 50 times I2 minus I3 equals 0. That's all three components. Okay, then I3, we start with that 50 ohm again. 50 ohms times now, since we're in the other loop, it's the other way around, I3 minus I2. And then since this is going from low to high, this is going to be negative minus 10 IX, because this is a dependent voltage source. Even though it has a current on the input, since it has the plus and minus here, this is a voltage source. So this is like, that is volts. You can think of, yeah. And then plus 10 times I3 minus I4 equals 0. And then for I4, since there's a current source, we can simply say I4 equals negative 4 amps. And then we have, since we have the dependent source, we have to write the, dependent source equation, or you could write this as the IX equation, whatever you want. And IX is simply going to be negative I2 because IX is defined as, this current but we've already defined I2 going the other way. So you can very simply just write it like that. And this would be the whole question. Cool. Yeah. Now I will do a couple what's it called? The superposition questions. And I had one somewhere that I was going to do first. Yes. So this is like probably as complicated as anything you would get on the quiz, I would hope. There's not really too much you can do with superposition and still have like enough time to do the quiz because you have to solve multiple circuits, right? They can't make it too complicated or else you just won't have time. So we got 6 ohms, 2 ohms, 3 ohms, 12 volts, and 2 amps. And we want to find this Vx. And the question is use superposition to find Vx. Pardon the handwriting, but you heard what I said. Okay, so what we do is we redraw it as like two different circuits. I will use some little arrows and I will start by neutralizing the source on the left because I want to. So we neutralize the source on the left. This now becomes a wire. And now we have everything else stays the same. And now we want to find Vx and we'll call it Vx prime. And to do so, you can do it really whatever way you want. For me, let's see, what's recommended by the teacher here? Oh yeah, okay. Here, since we're dealing with the current source, it works actually to use mesh current. So we'll call this I1 and this is I2. However, I turned off my iPad. My apologies. I think I pushed it into something. Come on, turn on. The screen share resume? Shit. Okay, cool. Sorry about that. So we have, I'll start by just writing like I2 equals 2 amps because we have that given right here. And then the other equation would just be that like for I1, we have I1 times 3 ohms plus 6 ohms times I1 minus I2 equals 0. And then we can kind of simplify this. So 3I1 plus 6I1 minus 6I2 equals 0. I2 we know is 2 amps, so this is just 9I1 equals 12. This is, because I2 equals 2. And then I1 would be 12 over 9 is 4/3. And then if we want to find this Vx, then the voltage through that 6 ohm resistor, we already said here. And this current direction agrees with this voltage drop, having I1 be positive. So we just take this again. So 6 ohms times I1 minus I2 equals Vx prime. And then we get Vx prime equals 6 times 4/3 minus 2, which is like, what is this? 4/3 minus 2. Whatever, you do the math, you get -4 volts. So this is our first thing. I'll draw a little dashed line down the middle. And then for our second circuit, we neutralize the current source. For the question, yeah, there's going to be one, I don't know for certain, but my guess is that you will have one write the equation of mesh current and one superposition question. If he wanted to, he can change it however he wants, but that's what he's done in previous years. So take it as you will. They do not share the quizzes with the TAs beforehand, so I'm just basing this off of like the Canvas pages I have from previous semesters. We'll call this Vx prime prime to differentiate it from Vx. And then we just solve this in the same way. One nice thing to point out here is that since there's an open circuit here, right, that means there is no current flowing. So what we can say is that this 2 ohm resistor basically doesn't do anything because resistors only have a voltage drop if they, you know, have current because V equals IR. If there's no I, then there's no V. So we can basically ignore that whole part of the circuit and then just look at this part here. And here, I will, hopefully you've learned voltage division by now. So you can very simply find this one as Vx prime prime equals that 12 volts times 6 over 3 plus 6, right? And that would be 12 times 6 over 9, which is, 2/3 of 12, and that would be 8 volts, right? Yeah. And then if we want to find Vx, we know Vx equals Vx prime plus Vx prime prime. Basically, it's the effect on this resistor by the 2 amp source plus the effect of the resistor by the 12 volt source. This would equal minus 4 plus 8, and that is 4 volts. Cool. And then, oh, the question actually said find the power dissipated. Let me write that. Power of 6 ohm. And oh my God, my microphone is right above my iPad, and I keep slamming the power button in the top right of my iPad into the microphone. Now I have to open up this and share my screen again. Okay, cool. Here we are. Okay, and then power. Remember, P equals IV, which means since V equals IR, we get also, I equals V over R. So then we can say that P equals IV equals, if I equals V over R, it's V over R times V for resistors, and that's V squared over R. So with that, we can get that the power is 4 squared over 6, which is like 2.67. And that would be your final answer here. Yeah, cool. Um, yeah, be sure to very thoroughly read the question to see if it's asking about power or voltage or current. I might make an announcement on that on tomorrow when you actually have the quiz, because people often miss that, and you will just lose points unnecessarily. Um, okay, this one's funky. I'll do this. So this question has multiple ways you could go about it. I will show one of them. But yeah, for a lot of questions in this class, there's like many methods you can choose. Now that you know like node voltage, mesh current, superposition, you can really do it however you want. Unless the question tells you to do it in a specific way, in which case you have to do it in that way. So, uh, use superposition to find power dissipated in 3 ohm res. So again, as we saw in the last question, power equals V squared over R. So this means just find the V. So I'll write that here. I'll say this is Vx. And we're going to do this in like the exact same way. I'll start by neutralizing that current source. 2 volts, 3 ohms, plus minus 6 ohms, 4 ohms. Okay, one key thing here is that when you okay, yeah, real quick, I'll go over this. I did kind of breeze over this section here. This is something called voltage division. Basically, in this circuit, right, it goes up 12 volts here. So then over these two resistors, it has to go back down 12 volts. And what you find is that for a given resistor, the like amount of voltage it gets is just like the proportion of how big that resistor is in comparison to the total resistance. So like so what we do here is we say, okay, the fraction of the total resistance of that in this circuit here is like 6 over 3 plus 6. So it's 6 over 9, right? This 6 ohms is 2/3 of the total resistance. So it will get 2/3 of the voltage. So what we say then is that, okay, the voltage across the 6 ohm resistor is going to be 12 times 6 over 3 plus 6. You can only do this when you have like a very simple circuit with like a voltage source and resistors in a series loop. Just as like another example, if you had 7 volts here and you had 4 ohms and 1 ohm and 2 ohms, right? What you can say is that, okay, this 4 ohm resistor would get the voltage across this would be 7 volts. That's like the input voltage times 4 over 4 plus 1 plus 2, which in this case, I guess this is a bad, it would just be whatever this voltage is. So if it's 7, then here you get, 4 over 7 times 7, which would be 4 volts. If this was like 8 volts, it would be 8 times 4 over 7, which is something. Likewise, you could say, okay, what's the voltage across this 2 ohm resistor? It would be that input voltage times 2 over 4 plus 1 plus 2. And that works out. It's a very useful thing. It just lets you skip some steps. It's cool. Back to here, though. We're going to use that again in a moment here. So here, what I was about to say is that when it tells you to find the power or the voltage or anything with a specific resistor, you cannot change that resistor. So when we're messing with like simplifying resistors, we're not going to mess with the 3 ohm resistor. However, these other two are fair game. So, we simplify this into all these two are in parallel. So what we got 4 times 6 over 4 plus 6, that's going to be 24 over 10, so that's 2.4 ohms. So we got this look familiar? Wow, we just saw a circuit like this. So this is 3 ohms and this is 2.4 ohms. So then I just kind of like took this and like rotated it, you know, and then we have it like that. Hopefully that's pretty clear. Um, so if we want to find the voltage here, so actually I'll redraw this to be a bit clearer. Um, you have 2.4 ohms, and that goes over here. So keep in mind that the sign given for this Vx, this is like Vx prime that we're solving for. It's actually in the opposite direction of the current that we'd expect to flow here. Since we have the positive terminal on the top, you would expect current to flow like that. So what we're going to get is that Vx is like a negative number here, but that's fine. So in the way I just mentioned, right? If we imagine current flowing out that way, right? There's going to be a voltage here, and it's going to be, I'll say negative Vx because the Vx is defined as the other direction. And that would be that input voltage times 3 ohms over 3 ohms plus 2.4 ohms. And with that, you get, let me find the math done for me. Okay. Yeah, you can do that and you would get, wait, what did they do here? This is so odd. Um, I disagree with the way they did this, but I guess it works. Give me a sec. This would, and anyway, it would end up getting you, I think, yeah, it would end up getting you Vx prime equals What it would be, I'll just pull out my calculator. Why don't I have my calculator out yet? Is my sign flipped? Um, I don't think my sign is flipped. 2 times 3 over 3 plus 2.4. Yeah, you would get negative Vx equals 1.11111, which means Vx equals 1.11. Repeating. Um, and then for the other circuit, what I was saying about the reason I made this negative, as I was saying, is because in this question, it gives you Vx with the positive being on top and the negative being on the bottom. But then when you actually get to simplifying this circuit, right, the current's going to flow that way because the positive terminal is on the top and is going to go from positive to negative. And that would actually create a voltage that is the other way. So just for the sake of writing out the equation, I'm saying it's negative. Cool. Isn't Vx supposed to be negative? Yes. Yes, it is. Okay. -1 volts. Okay. Then for the other equation, or for the other circuit, we leave that 4 amp source intact. I wrote the A before the 4. Um, okay. And then here we want to find the same thing again. So with this question, so we want to find that Vx prime prime. Um, I know I said earlier we don't want to mess with the 3 ohm resistor here, but actually in this case you can, because remember, things in parallel have the same voltage across them. So what we can do is we can combine these 3 resistors into one resistor because they're all in parallel. And then if you find the voltage across this resistor, it would end up actually being the same as the voltage across the 3 ohm resistor. Is there a better way to explain that? Maybe. But let me see. Oh, yeah, that kind of makes sense. Whatever. I like my way. This is one of those questions, though, where you can do it in like any way you want. This is how I personally would look at it. So I'll simplify it in 2 steps. As we saw earlier, this 4 ohm and the 6 ohm can get simplified into a 2.4 ohm. And then if we want to combine it with that 3 ohm, we'd have 3 times 2.4 over 3 plus 2.4, which is 3 times 2.4 divided by 3 plus 2.4. That is 1.33 ohms. So we end up getting that 4 amps and 1.33 ohms. And this is still our Vx prime prime. And then, V equals IR. Crazy. So we have 4 times 1.33, which gets us 5.33. I'll write that a bit more explicitly. Here, the sign is correct because we expect, given from the question, Vx has plus on the top, minus on the bottom. Can I repeat? When voltages are the same. When you have components in parallel, the voltage, they all have the same voltage because they're all connected on the top and they're all connected on the bottom. So if I have some voltage here and some voltage here, right? Then this one also has that voltage and this one also has that voltage. So what that means though is that if I were to combine all these resistors combine them all in parallel mathematically, then you're still going to have the same V1 and V2 here as you do up here. As the same as the one here. But you can only do this when everything is in parallel. Yeah. Um, so yeah, moving along here, we have 4 times 1.33, and that equals 5.33 volts. And then that tells us, or this is Vx prime prime. So then Vx equals Vx prime plus Vx prime prime, which is 5.33, or I'll write it the other way around, minus 1.11 plus 5.33, which gets us like 4.22. And then power is V squared over R, which is 4.22 squared over 3, which gets us 5.94 watts. Yeah. I have like 3 minutes left, so I don't really want to do another question. Does anyone have any questions for me, though? I'll wait like a minute. What about dependent source? I don't think you'll be given a dependent source question, but what you do is you just leave the dependent source in. You can't cancel the dependent source. You still only cancel the independent sources and then just solve the circuit as you would normally, leaving the dependent source in. It still works the same, but just the dependent source stays in while you cancel the other ones. Okay, in that case, I will end my recording.